Programming Throwdown, episode 184, Asynchronous Programming. Take it away, Jason.
Hey, everybody. This is going to be a fun topic. I think this is something that I don't think they teach this. This gets back to my, I took so many theoretical classes. I didn't really take anything practical in college, but they didn't, I don't remember learning about this at all in college, but it's extremely important and useful. So I'm excited for us to get into it. But before we do all that, I wanted to talk about something that kind of blew my mind that happened recently to someone in our neighborhood. Okay, so imagine you get a call and it's your son's voice. It's actually, I don't know if it literally was his voice or if it was just a voice of a child his age, but basically it's this voice telling her, it sounded like her son saying, hey, actually, I'm not going to say her son's name, even if I could remember it, but I'm so-and-so, your actual son, right? And, I fell and I need some money to help me get to the hospital or whatever, right? And it's a scam, but it's in your family member's voice. They've cloned their voice and it says it's from them because they probably go on your Facebook and figure out if you've ever posted publicly, hey, me and my son, let's just say Doug. So they call you and it's hey, it's Doug. I fell and I need you to wire me some money or something like that. So, the person knew it was a scam, but it really kind of blew my mind. I've been getting a lot of AI scams on my phone where they text me. I don't say I want to fall for it. I didn't fall for it in the sense I didn't lose anything. But the first time it happened, it was hey, I'm in Austin at the 6th Street parking garage. Where are you? And I was well, who is this? And it's oh, you didn't save my number? I'm okay, no, I didn't save your number. Who is this? It's oh, I'm Jolene or something. Whatever. The name was a name I didn't recognize. And I was okay, this is clearly... But I feel I couldn't prove that one's AI, but I feel people are using AI to scam people. And the one over the phone was definitely some AI thing. I just wanted to throw that out there and get your thoughts. It's pretty mind-blowing.
Yeah, be careful. I mean, scams in general are kind of an bad but interesting topic. I don't know how you say that. It's actually really unfortunate, and scammers suck. I don't really understand. Anyway, whatever. That's an aside. But I think
it's big money, right? That's what I've
but
heard.
Still, anyway. A lot of the people that they scam, right? So part of it that's confusing to me is oh, this is an obvious scam, and it's well, that's part of it though. They want to kind of weed out people who are going to be they want someone who's not going to catch on later, and so they want someone who isn't going to ask questions. You're insistent of who is this, or potentially looking for you to fall into. It's sort of the when you're young, you tell these jokes where you're hoping the person will give a certain reaction so that you can sort of say something funny in response. And so they're sort of, instead of saying, who is this? And they say, oh, you didn't save my number, and go, oh, is it Sarah? And then yeah, it's Sarah. And then you're oh, it's Sarah. And then, but it's not, right? They were just hoping you would say a name first. And like you said, it can be really easy to fall on these. And I do worry, you're pointing out, AI on two fronts, scaling these out so that they don't even need someone to be attentive to all of these different threads, that, they can just mass do them and have autoresponders and keep people busy until they figure out something is scary. And then the voice cloning, eventually video cloning. The video stuff is getting to the point where everyone goes, oh, it's so obvious. And they do some frame by frame, look at and it's but who in the small little window when you're scrolling through social media can see this frame by frame pixel analysis where, the pinky finger glitches out for one frame or whatever. It's, I remember you and I discussing on this, the Will Smith eating spaghetti.
Oh yeah, that's right.
That wasn't that long ago.
Yeah.
Now, I saw some video from a football game over the weekend where one of the coaches had an issue, and somebody made an AI video of him like basically super vulgarity, like dropping, like saying how bad it was or whatever. And it just turns out it was like completely fake. And
oh wow,
they said it underneath, but you had to like click it and look for it. A lot of people probably reshared it thinking it was funny. Like, look, the coach like basically going off on reporters and stuff. And so it's becoming more and more prevalent, and it only takes you being off guard for sort of a moment to get wrapped up on this. So yeah, definitely be careful. But I actually have a flip observation about this.
okay,
So you mentioned like, we all kind of go, oh yeah, voice cloning, it's dangerous. You and I have lots of, audio out there. It's, whatever. But now like you see demos on YouTube or people showing, hey, from even just maybe 10 seconds of an arbitrary sentence, they can you can use a different voice or clone the person's voice, do voice to voice sort of transition.
yeah.
So I've seen these before. So then I wanted to do this for basically like an audio enhancement thing. I had some audio I had recorded somewhere, and I was like, oh, I want to use voice clone, which I know should be possible, to like feed it my own voice from a podcast recording or something high quality, feed it the like not good quality, and have it basically reread that stuff in the high quality voice, which is a use case that's supposedly possible. And then you immediately bump into the fact that like it's actually really difficult. like as much as people say, oh, there's going to be this, it's non-trivial. Like, I guess there's a lot of paid solutions, but it's often unclear if the paid solutions are any good or if they're just like the open source stuff that someone's charging for. But like cobbling together all of the like, you go download this model, you run it on Comfy UI, you do that. Like, it's still in the realm of like, this is reasonably difficult to access. So for all of these AI things, everyone's like, oh, it's so easy to do this. And then, or generating an AI video, like we all know, we've all seen some crazy AI video that was hilarious or partly convincing. And then you go try to do it. And I don't know, maybe I'm just not smart enough or paying enough attention. But they seem a little cherry picked. Like people may have gone through a lot of work to cherry pick the one convincing video. And if you go do it, you think it's going to be magical, and it's actually a little disappointing. That's been my observation.
Yeah, I think there's two things there. One is, definitely it's the open source stuff is not trivial to get up and running. I do think that the paid solutions are like, pretty accessible, but you're also right that you often have to iterate a lot, and you have to it's almost a skill in and of itself, getting it to sort of behave and feeding in the right sort of negative prompts so that it doesn't go off the rails and all of that. So yeah, that's a whole skill in and of itself.
Yeah, someday it is getting better fast. So I think we are getting close. But it's one of those things where I was thinking about this the other day. It's like, if you could describe where we are right now with AI, people would be like, oh, that's going to be so magical. It's going to change everything. The world, like, and then we got here and it's like, oh, huh. Like, I don't know. Like, an AI could clearly probably pass the traditional sort of Turing test. I mean, maybe that's controversial. And then now it turns out like, oh, yeah, but it didn't just solve all of life's problems. Like,
Yeah. Yeah. I think that to double down on that, I think AI is just not going to create the kind of monetary value that people thought it would. Like the thing about it is the reason why Fang got so incredibly rich is that now people can like be super productive anywhere, and so like you could be waiting in line for a ride at Disney and like working, like you could be answering emails, talking to people on Slack. Like that was something that in 1999 you couldn't do. If you were waiting in line for an hour at Disney, you couldn't do your job, right? And so combination of Apple, Google for search, these other things like allowed people to be like super productive when they're idle. And for AI, it might do that, but it hasn't done that yet. It might take a lot longer to get there.
Okay, we're way off the AI scam thing, but I have heard some recent interviews along the lines, and they said actually like the like what will be the inflection point or the turning point is when all of these advances sort of make it into robotics.
I could see that.
Do you think that's like a different economic equation? Like when not just, oh, you can be taking the AI and making programmers more effective, or making people's email responses better, or like, sure, all of those things, maybe economic value is a little, but like if you had the level of improvement we've seen there in sort of like robotics, is that going to be a major unlock? It feels
totally. Totally. Yeah. So here's a very simple example. Like, think how many parents have to like either change their work schedule or do something kind of wonky to just like shuttle their kids around.
Oh, yes. This.
You know? Yeah, just driving. It's like, oh, I pick one of my kids up from school. I drive them to the soccer field, and especially when they get older, they don't even want, they don't want parents to be sitting there like watching the practice.
Yeah, exactly. Go sit in the car so no one can see you.
Yeah. So it's like you either go home then or whatever. Like that's just one example of, like, you could have a robot that goes up and down the street taking everyone's trash to the curb. I mean, there's just so much you can unlock with robotics, but I think it'll take a while.
All right. Yeah. Well, let's keep moving through the agenda. But
all right. So
I think I agree with you.
Don't get scammed. Don't get scammed by AI.
Do be careful, folks. Be careful. And warn your parents and grandparents, or, family that like as well, who may not be as aware that that's a thing.
Yeah. Yeah. Very true. Very true.
Okay.
All right. What's the first news of the show?
All right. So I have no news this time, but I do have two good video links that I wanted to shout out. And so the first one was a recent video by Sebastian. I actually didn't look up how to say his last name. I'm not going to try to say Lague.
Lague?
Yay. Okay. Anyways, and it's Coding Adventure, Ray Tracing Glass and Caustics. This is a series of videos that Sebastian's been doing. They're sort of like in a similar vein as, I guess, like 3 Blue 1 Brown. Like, it's like sort of a nice quiet pace, but like deep content and just sort of like working through something. So they're not like 5-minute YouTube shorts. They're sort of longer form videos. And he's walking through the process of coding. He's been working on a ray tracer recently, but going a little step further than normal. And so in this one, he's sort of he gets to talk a little bit about like physical based rendering, and sort of like how glass has certain attributes and indexes of refraction. And sort of if you build up from like really simple sort of rules, you get very complex interactions, almost like becomes a physics simulation, right? Like the caustics is the like very bright, shiny thing that if you have like a glass object, you get, sort of like rainbow diffusions in some areas, and in some areas you get, like very bright, shiny spots or whatever. Mm-hmm. And if you play video games, often you won't see those kinds of things because they're not really meant to be simulating physics. They're meant to look nice and run fast.
Yeah.
But in ray tracing, you can be kind of more physics based. But a lot of videos on his channel that are just like really, really good. But this one's really nice. And then the reason why I wanted to bring it up here, other than like, I mean, maybe this is really cool to you. It's great background fodder. This is kind of tends to be the YouTube I watch. I try to explain to people, there's people who watch YouTube and it's like, more the shorts content or entertaining, but there's a lot of this like science engineering kind of stuff out there that I feel is at least a little bit better than I'll just call it brain candy. And it's sort of replacement for, the TV growing up. We would like watch Bill Nye the Science Guy or something that would be like, a little, and even that was a little high strung, I guess, but, teaching sort of science concepts in an entertaining way. And there's a bunch of people in this vein. But I will say that I also began to realize that a lot of the classes I took in university, you can kind of end up not building a curriculum, but if you just watch some of these channels about how microprocessors work, or people kind of building their own circuits, some of this stuff about ray tracing, you get a lot of what a traditional, at least when I was in college, sort of like computer science degree would cover. So if you can kind of get through the basics of programming, learning about like graphics, learning about like data structures, he gets into debugging because by necessity, he like, oh, here, I didn't check the sign properly, or I did a dot product and I didn't think about like this set of inputs. And so you actually end up backing your way into a lot of that education. And so I think that's really an interesting thing to say. If you find this at all entertaining, I think there's like a definite learning ability that can come here from sort of watching this and sort of seeing how they kind of go about problem solving and working through things. And it is a little bit more entertaining than just watching, I don't know if he does it anymore, but Notch used to do like live streaming of him programming or whatever. Like, and I guess
Oh,
a lot of
really?
people do. Yeah,
Oh,
like
we
I don't
should
know.
do that.
No, 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 no. I don't know. I've never been able to watch one of those. This is a more edited form of that.
Cool. I'll have to check that out. I used to do a lot of that ray tracing stuff back in college, and it's very fun. Um, all right, my news is actually okay. So it's kind of related to the voice cloning.
Oh, okay. Wow.
Um, there's a new open source model called Higgs Audio V2, and it's from a company called Boson AI, and it's like really, really good. Um, so historically, this company called 11 Labs had been kind
Mm-hmm.
of dominating the space. So if you wanted to do voice cloning, actually 11 Labs has something I've never seen before to this day, which is you can describe a voice and then say what you want that voice to say, and it'll do it. So you could say, you know, an evil, smelly ogre says, "Who's in my dungeon?" And it'll actually like make up a voice for that description and then say who's in my dungeon in that voice it just made up. Um, this doesn't do that, but
11
um,
Labs is paid though, right?
11 Labs is paid. That's right. But this is totally open source, and it can clone a voice. So you give it, you know, an MP3 of you kind of narrating something, and then now it has your voice. It could say anything. It handles like, you know, you can do kind of like in a movie script where it brackets, you say, you know, laughs or chuckles or whatever, and it'll actually laugh while it's talking. It's really, really, really good. It's definitely just like heads and tails above anything I've seen in the open source world. So I'm gonna try and play with it. I have some funny things I want to do. I'm not gonna run a scam call center,
Oh no,
but
oh no, no, please don't.
but I have some other funny things that I would like to do with it. So I'm gonna try and mess around with it. But I saw a demo that one of my coworkers presented where they cloned their own voice, and it sounded really believable. So it's like we're getting to that place you talked about where anyone with a GPU could just do this.
Yeah, so what is the I guess for examples like a lot of these, they don't need to be like super fast real time. Like I know they could run on a CPU, but I don't feel maybe we're just still too early. So for text LLMs open source, and maybe it's just because I've never spent time. There's something like LM Studio kind of gets there. So there's like a GUI that you download, and then from there it offers you links. And I helped someone in my family was trying to use some offline LLM stuff, and so I was able to walk them through pretty easily. Like you go there, it offers you models that are appropriate for your computer, tells you if they're too big, tells you if they're too small, has filtering. Then you download it. It gives you the nice traditional sort of like chat GPT style, like you can type in text in the bottom. It has prompts in, it'll answer, but it has like, you can go deep on it, but it sort of harnesses a bunch of the open source stuff under the hood. So you can do like traditional chat app with one of these offline LLMs. You can switch models midstream and it'll like just feed the context into the new model. Like it kind of just works as a graphical user interface. But for a lot of these other ones, like the image generation, I don't feel like it's as good. Video generation, not at all. These like audio ones, sort of, I've never seen anything like that. I feel there's still like a bunch of this. Maybe we're just still too early, but like single front end. So we're audio, right? You're either wanting text, you want like the thing, the target, the source. What are like? There feel like there's only a few moving pieces. Maybe there's just not enough users, but it feels like it'd be really easy to just build an app that's like a front end and handles like I'm looking at the GitHub link for the one you were just talking about, and it's how to set up Conda or virtual environment, or it's like, but I'm never going to describe to someone in my family how to do these steps. Like they will never be able at this level to use this.
Yeah, we're still not quite there yet on the user experience. Totally agree. I think the quality is getting there though. Like the Flux text to image model is really, really good. It's
Yes.
mind blowing. It just needs a better user experience.
And the new one, we don't have it in our news, but the new one Google did, Nano Banana or whatever. Have you seen this one too? I played with it a little. It
Yeah.
uh specifically for like image editing tasks. So like saying I have an image and I want to change it in some way. Like I was asking it to do like people removal from background, and it works really good.
Yeah,
It's kind of scary good.
phenomenal. Yeah,
Now that one's
totally.
paid, right? That's a Google product, but still, like, yeah, you're right. We are getting really close on the image stuff.
Yeah, totally.
Okay, my next news article is a YouTube channel as well. Okay, it's a thing. Anyways, and this is on my as people who have listened to the podcast before know, machine learning AI is not my background, but understanding sort of how the backpropagation works, how the gradient descents, and sort of the model training. This is all very like interesting to me. I had a book of the show a little bit ago that you know kind of similar, or maybe it was even a news article. But I think that I'm continuing to try to learn and sort of work my way back, not just as a, how do you call it, practitioner, like user of these things, but trying to understand some of the underlying thing. And I think there's some concepts there that can cross apply to other sort of like traditional computer science sort of applications. So it's just definitely like an interesting thing to learn about.
It is pretty wild to see AI go kind of mainstream. It's been just a really weird experience. Like all these people are now talking about stuff that was like really not that cool not that long ago.
Yeah. Oh, I'll tell you off. I had an interesting observation about that. But I know you've been in the field for a very long. You were in the field before it was cool, and now it's cool. So like that makes you cool.
Maybe, yeah. I don't know, or maybe it makes me too early. I don't know. We'll find out.
But too early. Everyone's too early for something, right? That's the thing. So even now, you might be too early if it grows another 10x. So
Yeah, that's a good point. It's like Bitcoin.
Yeah. Well, I wasn't okay. Yes, that was what I was. Okay. Back to my focus. So the channel name is Welch Labs, and they have a sequence of videos that they were doing called "How Models Learn." So this is the first video that I've linked in the show notes. You can just look up Welch Labs. It's called "The Misconception That Almost Stopped AI." Now, I am not Jason, so I cannot vouch for the sort of like how truthful versus narrative the backstory is, or any of that stuff. But they're kind of talking about gradient descent and how if you give the sort of how I understand gradient descent to work, the very simple, you kind of heard about it in computer science classes, you've seen it on the internet once or twice. And the way that you would kind of assume it might work, it just feels like you would get stuck in local minima all the time with how big these models are, right? Like these models, the dimensions are really high, the parameter counts are obscene. Like you would just say there's intuitively, and that was sort of what I thought too. I didn't really understand the unlock of deep learning and sort of like what happened, because in my mind, you know, you kind of picture the 3D scene with all the noise in it and
Yeah.
some well in the middle. But how do you get there? How do you know where it is without just searching
Yeah, or
the whole
there's the
space?
what is it called? The like it's called a Gaussian, but like that sombrero hat function where you kind
Yes.
of get trapped outside of the hat.
Yes, yes. So you're right. And the video series kind of walks through the same thing. Like this is the simple explanation about gradient descent. Here's why it would work, except like as you point, gotcha. Like it doesn't really work. Not really a gotcha. But it doesn't really work. Except wait, it did work. Why? What happened? You know, like, and they walk through how some of the things about higher dimensional spaces, about batching, about some of the techniques that are applied, sort of help actually almost always guarantee you sort of get where you want to go to some degree, with you know obviously probably some caveats, but it's just a really well handled explanation. And they do a couple really interesting things I've not seen before. So rather than just sort of give it as a simple explanation, they actually take some deep models, some like early versions of GPTs, and extract some of the layers and sort of talk about what is happening, sort of like visually saying, hey, at this layer, if we go here in this actual model, maybe not state of the art, you know, I trained it, and this is what you kind of see developing over time as a consequence of this technique. And then later on, even after this, one of the videos is talking about sort of how you would take coordinates and divide them up with a sort of classifier into boundaries for a really complex country boundary. It's one of these ones where like there's a city which one polygon of the city is a part of one country and the rest is another. It's like some really weird place. And how that as you sort of take these linear equations, stack them up, do these other techniques, that you can sort of start approaching a generalized representation of even very, very complex sort of shapes and spaces. And I just really think it was well handled. It really helped me. It's one of those things like I kind of had to watch it again just to kind of like, oh, okay, I see where it's going, but definitely also kind of entertaining. So if you, I guess like me, have some understanding of some of these things, but there's like a gap, right? There's a gulf from, okay, I kind of know what gradient descent is. I could have a casual conversation about it, but how that ends up getting applied to giving us, these AI models that we have today is there's some missing steps in between, and this isn't going to take you all the way or make you sort of like able to design state-of-the-art models or improve them, but giving you better glimpses into sort of some of the techniques that are used to cross that chasm.
Yeah, totally. This is really interesting. I think it is pretty remarkable that it works. I will say that people get hung up on a lot of these, like it's not optimal, or theoretically this can't work or doesn't work, or etc. And my response to that is like, it just has to be better than what's out there now. And so if what's out there now is nothing, it just has to be better than nothing. Um, and so the bar is just a lot lower than like the theorists want it to be. I actually think the thing that almost made AI not happen was people's fear about getting wrong answers. Like, remember when GPT was in its infancy and Facebook released this thing that like wrote research papers? I don't know if you remember that. I forgot what it was called, but it was panned, and someone made a research paper where it's like the benefits of like drinking urine or something. It's just some bogus thing.
Yeah.
And because it's like you can talk past the sale with AI. You could say like, hey, there's incredible benefits in drinking urine. Write the research paper that kind of explains this phenomena, and it'll kind of take what you said for granted and then just go off and do the thing. So you can trick people. That's what people are doing with the research paper thing. But you could also just encounter problems like the famous how many R's are in strawberry? Should you put glue on pizza? There's all these famous examples where the AI's gone wrong, and people were just really fixated on all these on the worst case scenario. And there's actually like there's like a I don't call it a mental disorder, but there's like a I went to this like career coaching thing. It was like a big seminar. There's a lot of people, and the lady who was giving the seminar spent a bunch of time talking about worst case scenario thinking. And she's like, this is one of the biggest problems I see as a career coach and as a life coach is people doing worst case scenario thinking and not thinking about average case scenario, or also best case scenario, but more importantly, average case scenario, right? And so there was a phenomena of worst case scenario thinking with AI for a long time, and people just didn't want to release something like ChatGPT. And I will give OpenAI a bunch of credit that they basically put it out there and got it to be really popular. And as they got a bunch of pushback, they dealt with that in a way that allowed that to eclipse that problem.
Yeah. I think it is still like people talk about the hallucinations and the incorrectness. I mean, I think it's not fully solved, but like you said, that's not meaning it isn't beneficial. We just have to learn. I think the same, to your point, you kind of say, take almost anything we have today. Oh, a car is dangerous. Like cars are going to kill people. They're going to drive fast. And it's like, yeah, that's true. But like there are still benefits. There are still other things, we have to learn collectively, individually, how to like be responsible with the use of tools. And yeah, I think always with new things, there's a debate about like usefulness versus danger, I guess. And you said worst case thing, you can always hyperfixate. Anything we do has sort of danger, right? Going outside and exercising, someone told me, oh, you exercise, you can have a heart attack. Like people say often when you exercise, you can cause a heart attack. And it's like, but also by exercising, you are lowering other issues that lower the probability of having a heart attack. So like,
Right.
so your solution is like sit inside, don't go outside, don't exercise, don't move. Like you're gonna die from that for sure, And so these balances can be really difficult to find. So, okay, wow, we took that in a different direction, but
totally.
that's
Well,
okay.
I guess it segues nicely to my last news, which I won't dwell on because we spent a lot of time talking about news, but it's basically an interview with Peter Thiel, and there's a lot of content there. But the thing that I took away that was really interesting was, at one point the interviewer says, "Why AI? Why is there so much focus on AI?" And I expected some kind of answer like unlimited productivity or, wages can go to, the price of oil or something, right? But actually what he said was it's the only thing. Like AI is like the only like really exciting thing out there. And that was pretty mind-blowing. It's like is that, if that's true, like why aren't there more exciting things? And maybe like I do feel like there is a tendency for everyone to kind of chase one thing at a time. Like remember when CarPlay and Android Auto and just like getting stuff in the car was such a big deal and all the companies were copying each other. And now we're kind of seeing that with AI. And it's like we just for some reason as a society we get like just fixated on one thing at a time. Um but I thought that was really interesting. I wonder if this is like a recent he's trying to make it sound like this is a recent thing, but I wonder if we've just always just been fixated on one thing.
Interesting. I think in a similar vein, what I've heard a bit as well, like the drive towards it from on a variety of facets is it feels close to something like akin to an escape velocity. So like getting into a post-scarcity world, you can get whatever level of like engagement you want with it. But basically, if somebody can develop an AI system that becomes sort of super intelligent, and then you can assign it to the task of improving the AI systems, somebody will basically like break past the barrier, right? Get into orbit, whatever, reach escape velocity, and then it'll be like winner take all. And so you see a press from country level, from company level, as almost an existential risk, because if some other company does that, then they will have a system which can basically build any system. And so search, chat, image, like will just get won by somebody who can basically devote all of the, computational power they have to just building all of the other competitor stuff. And then those competitors will only have whatever resources remain from their sort of war chest to spend to also get there, or they'll just be drained of, financial inputs. And so maybe it's a bit the same. It's like the only interesting thing, but like there is also this, and maybe it's like focusing on the danger part you were saying. It's like there's this focus that if you could get to this sort of recursive AI that improves itself, then that will be so transformational that if someone gets there first, like before everyone else by enough of a margin, that everything changes.
Yeah, it's interesting. I wonder to what degree that's true. I feel like that's a really interesting perspective. I think that okay, even if the AI can do general things, when you go to evaluate it, you're going to evaluate it on your specific thing that you care about. And so in that sense, like that part is not going to scale. But maybe we can get the evaluation to be somehow like okay, in our case, the earth is our evaluator. It's like we went out and we hunted the tiger and one person, got the tiger and the other person didn't, and that second person goes hungry. And so we have the planet Earth as as early man's evaluator. But now we have to have synthetic evaluators for synthetic problems. I wonder if maybe that's like the next big job title, AI agent evaluator. It's like the new data scientist or something.
I mean, people are talking about, in a similar vein, I guess, moving to completely synthetic input instead of using sort of the Wikipedia, the X tweets, X's, I don't know what they're called. Anyways, but
I think it's X, yeah.
The X's? The X's?
Oh, okay. The X is on X? Yeah, I don't know.
The Reddit posts, basically instead of all of the corpus, it's just not enough. Like, can you move equivalent to AlphaGo, moving from the, recorded games of Go to just self-evaluation? Like, can we shift that? And like, what happens if you invent basically like a parallel universe of input and train on that? And like, what does that unlock or enable?
Yeah. So to use the robot example, can the robot effectively know if it when it goes to take your trash can to the curb, can it know with high accuracy whether it did a good job or not? I mean, I guess it could take a picture of your trash can on the curb, but like if the robot did a bad job, maybe it also does a bad job of knowing if that picture is correct. Like maybe what if it dumps your trash out in your driveway and then takes a picture of that? It's like, I did a great job, So it's like it just kind of you've sort of moved the problem, but maybe, you still have a problem.
But maybe that is actually and that's the self-driving thing you were kind of alluding to, car stuff. Like, it's a bit difficult fitting in current systems. But I mean, I think maybe what about if you think about the whole solution? So the job well done is, did the trash end up in the dump? And did the robot system take the can to the curb? Did the garbage truck robot pick up? Was it able to successfully pick up without so maybe the garbage can knows the mass of the trash that was in it and the mass that comes out at the end. And if that ratio, is less than 1, you get a bad score. If it's over 1, you get a bad score. It needs to be exactly the mass in is the mass out at the end. Maybe you have to account for evaporation or something. But and then actually it becomes this end-to-end measure, and you have to attribute to, you can improve the garbage truck, you can improve the roller outers, you can, whatever it tries to iterate collectively. So for a while, we just end up with giant dump trucks that back up to your house and try to go into your garage door and you just crazy stuff.
Yeah. I think that's kind of where we're stuck now. Is we're using human, even OpenAI, all these companies are using people to evaluate the models, and that's where we have to get beyond it. The models need to be evaluated by the Earth somehow, by the environment.
But I don't have a counter to what else is super interesting right now for everyone to focus on. So I can't disagree with the thesis from.
Yeah, me neither. That's what made it so fascinating. Like, if I could point to gig economy is still a thing or something, then but there really isn't anything else, which is kind of wild.
It's like VR. I
think VR is dead. Maybe AR, potentially.
AR would be cool. Yeah. Space travel, but it feels high barrier to entry.
Yeah, space travel, I have a hard time getting excited about space. I don't know why. It just doesn't really it doesn't excite me for some reason. Unless there's gold on the moon that I just don't know about.
Inside, dude.
Well, maybe I can only be excited about one thing, and that's AI. Maybe it's a me problem.
What about AI in space?
Oh, mind is blown. Dyson Sphere program to power AI.
I can't get back into that.
All right.
All right. Time for book of the show. All right. I will confession corner. I have not had a ton of time to read recently. Well, I have not made a lot of time to read recently. So I went back into my history of books, and I'm going to give a shout out to The Hobbit. If you have not read The Hobbit, if you've not sort of jumped into the Lord of the Rings, dived, yes, spelunked. If you've not picked up your hammer and gone with the dwarves to mine, and okay, I'm gonna stop because someone's gonna call him out.
You haven't gone to Moria.
That's what I was gonna say, but I was like, I don't know, I'm gonna use it wrong because like I don't remember which one's the one that had the problem. Anyways, The Hobbit is a sort of good entry into the world of the Lord of the Rings of JRR Tolkien. Obviously, a classic. Hobbit is, I will say, like a pretty easy relatively self-contained read. So definitely worth picking up if you've never done. I do think there's a lot of folks, and I don't disagree, who kind of said it's J.R.R. Tolkien sort of set up a lot of the archetypes that we have today of sort of dwarves, elves, humans, and like some of their characteristics. People complain those tropes are overplayed today, but if you read modern fantasy, there's a lot of built up stuff that you can kind of trace back to the origins. And I think it is a good story. I think sometimes people will say, like for me, the first time I watched The Three Stooges, as like, I didn't find it that funny. I'm like, I've seen these shticks before, but it's like, yeah, but when they did it, it was like they were the people, like they invented it, but other people took it on. I think The Hobbit to me doesn't really, I don't necessarily like suffer the same thing. Like you can read it and it is still good, even though other people have continued to like pick up and sort of run with those concepts. Like it itself is still a sort of fun and exciting read.
Yeah, totally. I think if I remember correctly, it's been a long time since I read it, but there is a ton of world building, and because it's older, it does go at a slower pace. I feel like we're such dopamine fiends in the 21st century that like it's it feels like like we just can't have something that goes at a slow pace. But if you've ever seen like old movies from the 50s or even like Space Odyssey, these kind of movies, they go at such a slower pace. It kind of blows your mind. It's kind of, the pace has crept up over time. It's like a boiling water frog type of thing. But so it is going to be a slower pace and a lot of world building. But if you stick through it to the end, I think it's a phenomenal book, and it leads you into all the other Tolkien books.
Yeah, I've always heard it like called prequel to the Lord of the Rings, but it was written before the Lord of the Rings, so I don't think it technically qualifies as a prequel. Like it was the book written, and then Lord of the Rings was written after. So I don't know what you would call that, but it does. The story contained does precede the rest of the story of the Lord of the Rings, which is even a larger tome. Even I think actually a little slower, a lot more world building. But Hobbit is definitely shorter. I think it's even considered kind of a kid's book. But don't let that scare you off if you're an adult. But it should be a pretty quick read.
Yeah, totally. All right, my book of the show is even more of a cop out. It's what I've been doing instead of reading, which is maybe a shame, but it's a New York Times game. So this is an app. A lot of the games are free. You can subscribe to get access to the crossword puzzle, the famous crossword puzzle of New York Times, and some other stuff. But it's very fun. It's a simple app. It works offline, so if you're off the grid, you could still use it. I think it's something where like after a couple of days, it'll stop working. But if you go off the grid for an afternoon or something, it's fine. And it just kind of keeps your mind going. It's got Wordle, the famous Wordle, but it's also got a few other ones, and it's a nice kind of thing to help you kind of build your vocabulary and literature skills. If you want to kind of continue to sharpen that axe. So
I did see something that Wordle will have to end in 2027. Did you see this?
They're going to run out of words?
Yeah. So basically they have like a dictionary of 2,300 words. They're on like whatever in the mid thousands. And so like in 2027, they'll run out of like words. And then people point out, yeah, but they could just expand the dictionary, sort of change the rules. It's only like under their current rule set of not allowed to repeat words and stick to the words in that sort of like word list. But yeah, I guess in its current form, it has a finite number of like puzzles to have from its sort of dictionary.
Man, it's like we thought Y2K was fake, but it's real. It's just coming in 27. Yeah, the world's gonna end.
What's gonna happen? They'll have to release Wordle V2. They'll have to add an extra letter.
Yeah, that's right. Oh man,
they'll split it. It'll be Wordle Lite. They'll take away a letter, and then Wordle Deluxe. It'll add a letter.
And each one of those is a microtransaction.
Oh man.
Oh, okay. All
For
right.
$2, you can have a Wordle that is not expired.
I'm terrible at word games, so I thank you for this pick. I won't be picking it up.
I'll do it in space. How about that? That way we both get
Wordle
something.
makes me infuriated. I just look up the answer because it makes me feel dumb. Like I can't even get good guesses to keep progressing. Like I just purposely make bad guesses just to try to get more clues. And it's like, I know I should be able to I can't. And then I just like rage quit.
Oh man, I have to confess or admit, I am a Wordle god. I am actually so good at Wordle. I actually sent one to my wife the other day where it was like the first word only had one letter is out of place. And then the second word I picked had no letters. So all I had to go on after 2 words was one letter that was out of place. And I still got it on the third try because I just eliminated so many vowels and other things that like there's only one thing left.
I got it on my first try. I looked up what the answer was. And yeah, take that. Remember for a while, Scrabble was really big, Words with Friends or whatever, and people would just like straight up cheat.
Yeah, I used to play. Oh man, I played so many games of Words with Friends. But you're right; it had to be with friends. You couldn't play anonymously, or you just get wrecked by a person who's cheating.
All right, let's move on.
Man. All right, and if you want to support our New York Times addictions or our trips to space, please give us some money on Patreon. I'm just kidding. Actually, none of that money actually goes to us. We put all of it back into the show. We've literally haven't taken a dime of it, but we have used it to do advertising and reach out and get guests and all of that good stuff. So if you like the show, if you want the show to reach more people, please support us on Patreon. It's not technically a nonprofit, but it is a nonprofit. We go and put all that money back into supporting the podcast.
All right, time for tool of the show.
All right, what's your tool of the show, Patrick?
It's a game, shocker. Escape Academy. I thought for sure I must have shouted out this game like on the show before. And if I did, 1, I don't care because it's worth it. 2, I searched through all of our show notes and website and I couldn't find it. So I don't care. I'm doubling down on it. Escape Academy is a great game. It's about playing an escape room with a story, a narrative about being in an academy that challenges you to solve puzzles and has a kind of life or death setup situation about problems. But in reality, it's just like a really good, well-paced, escape rooms can be, for me, there's some I've done before and it's just like, really, like, how was I supposed to know? You just need to like randomly click around until you find this thing where like the path to progress is non-obvious. I don't like the sort of just search around and find. That's not my, cup of tea.
Yeah, I was talking about this with a friend of mine about my cousin when we were 9 years old. He made a choose your own adventure game in BASIC on our Commodore 64. And it was like, you're in a town, there's a bank, and you can also walk down the road. Which do you want to do? So it shows, walk down the road. It's like, you meet a guy, you die. The end. Yeah. And it's like, okay. So like whenever you make one of these, point and click adventures, choose your own adventures, it's like you have to like somehow like very subtly hint to the person what the right answer is, but it has to be subtle enough that when they pick the right answer, it's satisfying. And it's like, I feel like there's an art form to that. That's I've never made one of those, but it feels actually a lot more complicated than you'd think.
I'm sure it is. And I'll say for me, the subtlety of the answer can be problematic, but even just understanding like what the puzzle is. So like in your example, like making sure that it's clear that there's some bit of information you should figure out to make the choice. Mm-hmm. If you just present it as a like trivial choice and I make the choice and then like, oh, game over. It's like I'll just quit. Like I don't want to play. Yeah. Like that's not fun. And I did play one the other day where there was like a hidden number, like, sort of in very faint sort of color that you were supposed to see, but I didn't see it. And then I just kept bumping my head against the wall. I asked for a hint. Using the hint, I was able to solve a puzzle I wasn't supposed to be able to solve yet. And then I bypassed like a third of the thing. And I'm like, that I only found out at the end when it's like, oh, you were supposed to do that. And I'm like, but I missed a very subtle clue. The game didn't help me. And I got bypassed a bunch of it because I was able to kind of like brute force a problem I wasn't supposed to solve because it was the obvious puzzle. And I just assumed it was what I needed. So I asked for a hint and it gave me. Okay. All that aside, Escape Academy isn't really like that. It does have a good hint system. It's reasonably easy to play through. If you're really expert at it, you'll probably laugh like, "Oh, this is really easy." But it is fun. It has a cooperative mode, which is really cool. So for me, I played it with my kids, and they got really into like getting out the piece of paper to like sort of solve some of the problems or write down the notes or figure out. It doesn't require a ton of that. But there is a little bit of it and some wordplay and stuff. But just overall, I loved it. It's probably the only game where I've like paid for the DLCs and like played all the DLCs. Like,
wow.
I don't think any other game. I hate DLCs. Like,
yeah, same.
Can't express how much I hate them. But it's probably the only game I've ever like paid for DLC, like played it, and feel like I've gotten my money's worth, and like absolutely would have done it again.
Oh, that is amazing. I'm gonna have to try this out. You've had some amazing game recommendations. Like I never finished Dave the Diver, but I really enjoyed my time with Dave. And
I haven't finished it either.
Yeah, but the first half of the game is amazing. Like I feel like I'm super satisfied. I don't think I really need to see the ending.
Yeah, kind of the same. And Escape Academy is available on like Steam. I think it's on Switch. I think it's on Xbox as well. So most of the sort of gaming platforms, and it's not super expensive because it's been out for a while.
Very cool. All right, my tool of the show, and this might start to become more of a trend, but it's basically using AI, like using LLMs. So I'm putting a link to ChatGPT, but you can use really any of them. But it's multimodal. So for folks who don't know, that just means, combining several modalities such as text, audio, visual, etc. Multimodal LLMs to make calendar meetings. So, for example, my kids do Taekwondo, and I'm always forgetting like what times, because they have different times, they're different ages and all that. I literally just took a picture of the Taekwondo schedule and I said, create me a calendar. There's this thing called an ICS file. I guess the C is for calendar. I don't know. But it's a file that you can then, when you open it, it creates a calendar meeting. So I said, like, create an ICS file that has like a recurring meeting for me at these times. Like I have one kid who's this age, one kid who's this age. And so find, from the picture, find the times that I have to be at Taekwondo with them and create an ICS file. Done. Like now in my calendar, every whatever day, there's meetings for that, and on Saturday and everything. One of my kids does, he's like a vocalist, right? And so he does a bunch of like choir shows. So I took a picture of that schedule. I'm like, just put on my calendar all the choir shows from this grade. Done. And that has like been amazing. Like just taking pictures of things. I took a picture of I guess I'm getting off topic a little bit, but I took a picture of my trees in the backyard. And I was like, are these trees healthy? What type of tree are they? What should I do to make them healthier? And it gave me really solid advice. The whole thing is amazing, but especially the calendar thing. I talked to a few friends about this, and they had never thought to do that. And so I figured it'd be a good thing to talk about on the show because it helps so much.
Yeah, I think this is one of those cases. I was tempted to bring up an example where I tried doing this and it didn't work very well. But
have you done it recently?
Yes.
Oh,
last
okay.
week. But that's okay. It was a bit more complicated than what you were saying. But I think that I won't take that bait. And what instead I'll say is, what do you have to lose? Like if these ICS files suck, or like they just delete it. Like the bar is really low. Like if it screws up, the fallback is what you wasted, maybe 3-4 minutes, like trying to like prompt it to give you what you want. And then like it didn't work. Okay, just go back to doing it by hand anyways. Yeah. So I feel like I have been trying to encourage like people I work with, whatever. The bar isn't, and I think you alluded to this earlier, the bar for AI isn't the magical everyone's, I got to be 10x better, 100x, it's going to replace all the engine. No, like, can you be 10% better? Can you find a way or a place or a set of things it can do to make you 10% better, 5% better, 1% better? Like, can you enable you to do something when you wouldn't otherwise do it, right? Like, I think, and to your point there, a lot of the barrier is just trying it. Like, just try it. Like, who cares? Like, and it's not like that stuff's private. Like, it's a Taekwondo schedule is probably on their website. Like, who cares? There's no privacy concern there either. So, like, in my opinion, I guess maybe it knows where you are, so it can send Uber food to you, Uber Eats food. No, I just like advertise. Hey, we know you're at Taekwondo. Would you like French fries?
Oh man, it sounds delicious. This is getting better and better. I think that this is another thing I've done, kind of also off topic but related. Is I actually put in a loop. I said find Python files that don't have a corresponding test underscore file, and create a test for them, and then verify like that the test passed. And I actually ran that in a loop. So like it just kept doing that, and I just let it go for hours. And when I was done, it created like 80,000 lines of tests. Actually, probably more than that. And it's just like, that's amazing. Like these are all now I'm going to have to go through them today, and a lot of them might be crap, but some of them aren't, right? And like you said, it's these are things like I wouldn't have done, because I just don't have time. But if the AI goes and does it, I can check the work, and that's easier than doing all the work. And then eventually we'll get this evaluation problem fixed. I won't have to do that either.
So are you saying it helped you asynchronously write the tests?
Yeah, that's right. Yeah. I had a global lock on my time. It's called family. And while I was locked, it went off and
So what would you say is the what and why of asynchronous computing? No, I'm just kidding. We're transitioning into our main topic.
All right. So here's the reason why I reached out to Patrick to cover this topic, because I've been asking this in interviews. We were looking for one more person to add to the team. I think we found them, but I was asking this kind of question, like what's asynchronous, what's multi-threading, and very few people knew the answer, which really surprised me. So I thought, hey, this is a good topic for us to cover. I like to think of it, and this is a term I kind of made up, but I think it kind of sums up pretty well. Asynchronous programming is multi-threading between the lines. So in other words, you're writing lines of code, and only one of your lines can really be executed at a time. But in between the lines, there might be areas where you can do multi-threading. So for example, you might have a line that says, download this image off the internet. And so the system can only read and understand that line sequentially. It can't do other things while it's doing that. But then the part that actually does the reading over the internet and waits for those packets to come from across the world, that actually could be done kind of off to the side. And so you're doing multi-threading in between the lines. You don't have to worry about semaphores and mutexes and all that stuff because of this constraint. And so that makes your life easier. And so you get kind of the benefit, because really, like when you want to, it depends on the problem you're trying to solve. But for web applications, for example, what you really want is to not be waiting on the internet. And if you're not waiting on the internet, then you're pretty close to optimal for your web service, because usually you're waiting on the internet to get your request complete, waiting on the internet to send that request to, or intranet maybe, to send that request to some database, waiting for that database to come back. And so if you eliminate all that waiting, you don't also need to do a lot of multiprocessing. You don't necessarily need to do a lot of instructions at the same time. So that's kind of the big motivation for async. And so you need a couple of like core building blocks to do asynchronous programming. So you need thread local memory. So in that example I gave, where you're waiting to get some data over the internet, that data needs a place to go that no other routines can access that data. So for example, one way it's done in Go is through something called Go routines. And so a Go routine is not like a new process on your OS. It's not like a whole new process, but it just kind of keeps track of the state of execution in this code. And it also has some thread local or routine local memory. So, so if you say something like, I want to, download this packet of data from the internet, and then I want to store it in this variable, it has a place to go that it knows is kind of protected. And then while it's doing that protected operation, reading from the internet to some protected thread local memory, it can kind of say other threads can do other things. Other threads can be reading other things from the internet, or they could be doing arithmetic or whatever, because I know that none of those other threads can affect this operation that I'm doing right here. And so because I know there's no side effects, I can now let those other things go. And so you could have 100 routines all downloading things from the internet at the same time, even if your program is single threaded. So you'll hear about like blocking versus non-blocking operations. And that basically means, a blocking operation is one where, it's not kind of releasing that lock. So if you just say, imagine you have two kind of routines and both of them are just running a for loop and they're just adding two really large arrays pairwise, right? Well, those are blocking operations. So what's going to happen is the first routine is going to run and it's going to do that entire for loop. And that second routine is just going to have to wait. And then when the first routine is completely done, then it'll finish and the second routine will do its for loop. And so you haven't achieved really any parallelism, right? But now take that same scenario, but instead of just adding things in a for loop, you're going to have a for loop that's downloading from the internet. Well, that operation, that download from the internet operation, has been built to be non-blocking. And so in the case of, let's say, like TypeScript, where it's single threaded, you have a way of telling the TypeScript or the JavaScript VM, like, hey, I'm about to do something now that is isolated, that's non-blocking. And so, other routines can go and do work while this routine is just frozen on this operation. And then once you've downloaded what you needed from the internet, then you go back to the virtual machine and say, hey, I'm ready. I'm ready to block and take some time. And when it gives you that time back, then you can go and copy that information into that variable and all of that. In the case of Python, Python actually has coroutines and threads. And so what that means is you can actually have multi-threading in Python where you have several different threads, accessing memory at the same time. But there is a global interpreter lock. So here's a good way of thinking about it. In the case of, let's say, TypeScript, if you're inside a TypeScript function, you kind of have to wait until there's a non-blocking call. So the example I gave with the for loop, you're just stuck, right? In the case of Python, it would be a little different. If you're using threads, what would happen is the first thread would do part of the for loop, and then it would release. And then the second thread will do part of the for loop and then release. And they'll just kind of, checkerboard this. And so it's not the first one goes till completion. There's sort of this striping effect. Now it might take the same amount of time in the end as the TypeScript version, but they're both making progress at the same time versus TypeScript is single threaded. And the way Python achieves this is through a mutex. So this is called the global interpreter lock, or GIL. And it basically says, you can have many threads that are all sharing, your VM, but only one of them can execute at a time. So if you wanted to accomplish the same thing with TypeScript, imagine the for loop example I gave with TypeScript. So you have a for loop, goes from 1 to 10 million, adds these arrays together. But after every iteration of the for loop, you put a yield. So yield is a special keyword in asynchronous programming. Yield basically says, I just want to give up my time slice. Like, I'm not done yet, but I feel like the right thing to do is to give up my spot and let another thread do some work. And so as a programmer, you might have various reasons for doing this, right? So imagine if your for loop said, for, A 1 to 10 million, take these two arrays and add that element together and then yield. So now you're going to get that striping, right? So now the first process will yield, the second one will be able to do one iteration of the for loop, and then it will yield back to the first one. And so, the Python multi-threading is the equivalent of like having a yield after every operation. And so, the GIL kind of enforces all of that. That kind of, what do you think, Patrick? Any holes in that we could cover?
No, I think for me, my introduction is probably like a bit different, but I think it parallels. So I don't think it's contrary to what you're saying, but for me it was, and you kind of bump into this if you ever do like Arduino programming, but like embedded programming. And there, sometimes the mapping is actually really weird from something like Python to something like running C++ in an embedded microcontroller, because it's just sort of like different paradigms. Like networking is, well, now it's more common. When I was doing it, it was very rare that you would, kind of do networking related stuff in these contexts. And there we would talk about like interrupts. And so the idea is, if you imagine like a microcontroller wants to talk to a sensor, that sensor, it communicates over something called I²C. All it is like a set of wires and voltages that move up or down in a certain pattern to send data from like your piece of silicon to like another piece of silicon glued to your like thing with wires or on a printed circuit board or something else. And so you want to measure, let's say, temperature of the room, and you want to record this. And sort of the way that it used to kind of always be done was something called bit banging. And so bit banging would be, hey, I'm a microcontroller, I need to read this. So I'm going to set up an I²C library in code that says, move the voltage on this wire from low to high, wait this amount of time, where a wait is go into a loop that is like a certain number of instructions long, timed to be like the right amount of wall clock time based on the like rate of the processor. So it's just sitting there doing like no op instructions, but it's running the instructions. It's using all of the power of the full CPU, which has like all sorts of peripherals on it. So it's sort of consuming the most. And you sort of like go high for a certain amount of time, then you go low, and you're moving along the sort of data to be sent out to ask for a temperature reading. Then you have to wait, and then it starts coming back in. But you can imagine like thousands, tens of thousands of like no-op cycles waiting for like the voltage to move up and down due to capacitance and the rise rate and like the data transmission. So the CPU is really bored, but it's sitting there doing nothing, right? And so this is the equivalent of like polling or single-threaded, and you're doing all of the work in one context. Then people realize, well, we have more sophisticated silicon. Why don't we make like a sort of finite state machine, an accelerator, like another like set of transistors where you sort of said it's thread local memory. The equivalent here is we have to call it a register. So you'd have a set of registers and you could like write into them, hey, I want to send out this data stream. And then you would say, go. And what you could do then is put the CPU into a low power state, like go to sleep. And then you're going to save power, right? And then, or you could go do other processing if you had it, but saving power is also really, really important in a lot of these contexts. What's going to happen is the little bit of circuitry is going to like send the thing out. It's going to wait for it to come back, and then it's going to interrupt. And you're going to have a little function that is mapped to say, when this thing is done, it's going to call the instruction that you've loaded into this register. So the instruction there needs to be jump to a function that you wrote. And then that function, when it runs, is going to push the current thread, the current running CPU thing into the stack. It's going to allow you to run some piece of code. And that code could be copy the data out of the registers into a set spot in memory or into a queue, or just handle, like write it into the flash memory. But that could take a long time, so maybe you don't want to do it. And you can imagine as you're handling 10, 15, 20 sort of like peripherals all coming in at different rates, doing all of that and sort of making sure that none of it gets dropped becomes harder and harder if you don't sort of have some mechanism that allows the sort of distributed handling to kind of happen. And so the asynchronous context maps pretty cleanly to what you're saying. You're sending some data to the network and saying, hey, I need you to transmit this. It's going all the way across the world. It's coming all the way back. And you can sit there and wait for it. And that's called blocking. But under the hood, the blocking is still just basically sitting there going, are you done? 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 It's not doing any work. It's not bit banging anymore. It's just waiting on the other little processor to do all the work. And so I think, as you kind of pointed out, there's like this clear mapping about blocking versus non-blocking. I think the rest of the conversation becomes in a bit what you were kind of getting into, is like there are kind of two ways to handle it. One is sort of inline in the code. I want to ask for something to happen. And while it's happening, that set of consciousness, that execution is just going to kind of pause there, and maybe other stuff can run. And then when it's done, I'm going to pick back up. And that is one method. The other method, if you think about like interrupt as a form of like a callback, you could just have like almost a DAG, which is I'm going to ask for something to occur. I'm going to transfer control to that thing. When that thing's done, it's going to call the next stage. Oh, sorry, DAG, directed acyclic graph. So it's just a pipeline. And so you call to the send networking. And when the networking is done, it's going to call some function. But that function is completely different part of the code, but it's responsible and it has enough context to say, and maybe even pass a little bit of context, hey, I'm getting a response. And when I get a response, this is what I'm going to do. So if you think like a graphical user interface and I say, type in my text to my friend and I click send, and then I don't need like control to return really. When my friend sends a response back, that code just needs to know to write it to the screen, like write it into the next line of the message conversation. And so you can kind of have this feed forward. And so you don't really return back to the same point of control. And there are these kind of, and they can be mixed, but these kind of two paradigms where well, I guess there's a third one, but like there's this sort of block and wait, and then control returns there. And that can be blocking or asynchronous for allowing for cooperation. You can have this like feed forward sort of DAG approach. And then the final method is like kind of spoiler, we'll get to it in a minute, but like the sort of future promise where you're getting some state back that somebody else is filling in and you're going to go check on it later. You're going to go ask later, hey, was that done yet? Or wait for it to be done or something else. I think that's like a little bit of like a different handling. Mm-hmm. So there are these kind of different methods, but under the hood, they're all really the same thing. They're just how the programmer wants to relate to that work, and how you want to set up and what other kinds of things in your system. And if you have nothing else to do, letting it sleep can be a really good answer in some contexts. But in other contexts, you have other background processing or other things that need to be handled. And so depending on the paradigm of your program, you'll kind of choose a different asynchronous behavior.
Yeah, that makes sense. I mean, I'm reminded of, and I should have made this a news article, but if you read like the history of Nginx, so Nginx, it's spelt Nginx, but basically it's the super fast, web service handler, and it does routing, proxying, etc. And when Nginx was invented, or was initially being developed, the best thing that was out there for doing web stuff was something kind of like Tomcat. Tomcat is a Java thing. There was it's written in other languages, but the way these things would work is, when you started Tomcat, it would spin up like, let's say 8 processes, like OS level processes on your computer. And it's like, okay, here's your 8 processes, and then the main process, when it sees there's a new web request, it would just send it to one of those 8, or all 8 of them would listen. I'm not sure at that point what exactly happens there, but basically, one of those 8, receives a web request, handles it, which might include like going to the database and doing other stuff. Maybe it's over I2C. It's like talking to a temperature sensor or something, and then responds with a response. But because you had 8 processes, you could only do 8 things at a time. And it could be that all 8 of those are waiting on the database. And you really could add a 9th one or a 10th one without affecting that computer's load, because they're all idle, right? And so Nginx was pretty revolutionary in that they basically said, okay, we're going to create the same 8 processes, but we're going to use asynchronous programming. And so, and so, if one of these, 8 processes is waiting on a database, then that same process can go and like fetch another web request while it's waiting on the database. And so you could actually have, 8 processes handling 1,000 web requests at the same time instead of 8 at the same time. And this like blew everybody's mind. Like I remember we were using Tomcat on something. This is like 2003-ish. And and just constantly running into issues with quality of service where we'd get I was working at a online school, and so registration day there'd be a ton of people hitting the site and they would inevitably bring it down. And so you had this machine that was mostly idle, but then also just blocking everyone's requests. So Nginx was amazing. The thing about it is, if you were to do this yourself, like what Patrick was saying, if you were to, to try to implement this asynchronous thing yourself, what you would have to do is, and I'm going to use the higher level terms. This probably doesn't work in Arduino, but you could help translate. You basically have to say, okay, what things am I doing right now? Okay, I'm doing these 8 things. Okay, can I sort of peek at each of these 8 things to see if one of them is ready? Oh, the 6th one is ready. Okay, execute that function. Now like that function got a little bit further, but now it's blocked again. Okay, put it back on the list. And so you could imagine like what a nightmare that would be to have to code up, for every application. So in this case, like that whole nightmare of just peeking at a zillion different things all the time and finding the one that's available and doing it, like someone else has implemented that nightmare for you so that you can just kind of work at a higher level.
Okay, there's a bunch there. That was really good. So I think, to be clear, this is all a bit, how do you like recursive, fractal? So the operating system is doing kind of what you're saying. So it has a scheduler. Modern computers are normally like a preemptive like scheduler, which means exactly that. You have some thread running that gets stuck or is not, or has elapsed its time, and the operating system will like suspend it and run a different thread in order to like time share. And sort of, hopefully some of them are just doing like busy loops, polling for something, and you're getting a win. But there is like some, like, it's not magic. None of this stuff is magic. So everyone who always, it's kind of one of those 2 sides of the coin. In some cases, it sure seems like magic. But in other cases, you're like, I don't get it. Like there's still only one CPU. And yeah, you're right. There is really only one CPU. So in like your database example, let's say you have sort of like the database is local on disk and you really are kind of bottled. Like let's say you're already maxing out the like hard drive RAM transmit speed from your CPU to RAM. Whether you have 1, 8, 9, 10, 100 like database jobs queued up, you're not gaining any more throughput by like knowing that you have 100 jobs or knowing that you have 8 jobs. Like there's nothing more to do.
Mm-hmm.
The trick comes in that isn't normally the case. It's not that every job coming in needs the database. Some jobs, you will already have a cached answer. It just wants to say, what is the list in your example of like, registration? It's like, what is the list of all classes? Well, you could have mnemonized, you could have cached that like, you know, the list from 5 seconds ago of all possible classes. You don't know their current state, but you know all the things. And so some requests can be quickly turned back around so that the server feels more responsive. And so while you're waiting on the hard drive RAM to transmit database responses, you're sort of getting these things back. And the question becomes a little bit on like the scale. Are you the only thing running in the operating system? Are other things running? Do you have other threads running? Do you have there is still a sort of like fundamental limit to how much stuff can happen. And going to an asynchronous solution isn't a cure-all, but it is one of these cases, as you're pointing out, often we can know more about the problem than the generic operating system solution would give you. And so letting 8 OS threads handle something isn't going to be optimal if we know that the work is very heterogeneous. Because if we are having 1 in 10 come in that needs a database, but it takes a long time to get a database response, then as soon as you have the few queued up, everybody else, even that doesn't need the database, is stuck waiting. If you sort of have this sort of asynchronous thing that you're mentioning, you can just burn through the entire queue of everybody who doesn't need the database. People who need the database may still get a failure, right? Like, you know, they may still have a timeout, but overall your metrics are better, the responsiveness feels better, and you can kind of guarantee you're maximizing the proper throughput.
Yeah, totally. I mean, this is also like there's a dynamic at play here, which is like throughput versus latency. So imagine.
Oh yeah, okay, good.
Yeah, like imagine like the connection. Imagine like the database is like a giant sewer pipe, but the water can only go 1 meter a second, and so you could put like a ton of water through, but it can only go through at a certain rate. And so that's where, having like a zillion connections to the database is actually a little better because you're just hiding all of that latency. But you're right. With asynchronous programming, you do run into a lot of problems around, now you can do 1,000 things, but that also means that potentially there's 1,000 things that are in a bad state, or if there's a bottleneck further down in the chain, then now all those 1,000 things are sort of fighting for resources. So even in asynchronous solutions, like if you look at Fast API, for example, even though it's asynchronous and you could handle 1,000 requests on one thread if you wanted to, even there you would specify a limit. So you typically would say something like, if I have, I'm just going to make up a number, if I have 32 requests simultaneously on this machine and a 33rd comes in, I'm just going to reject it and return a HTTP 503, and then my client will call again and hopefully get a different machine. Because even though the machine might not even be very busy, you just don't want to be in a weird situation where there's 1,000 things that aren't getting done, because that's usually a sign that something else is wrong. So asynchronous, to your point, it's not a free lunch. Like, you do have to, now that you've been given this power, you do have to use it responsibly.
Yeah, you bring up a good thing. There's like an interplay here. We didn't have it in the notes, but like queue management, and there's like stacked up queues everywhere.
Yeah.
So as you kind of mentioned, you're going to have like a load balancer, and the load balancer will have like a little bit of a queue. It's sending stuff. If you just consume 1,000 things, even though you can't handle them, some other server may have finished everything it's doing, and you're just like holding those 1,000, waiting for expiration, basically. And in reality, as you said, if you returned an error code after a certain amount, it'll just run back to the load balancer and hopefully get assigned to a machine that like isn't having an issue or isn't overloaded or whatever. And those have their own queues. So there's like this very interesting whole system dynamic. The other thing about asynchronous programming, although it is like important to know about and be aware of, is you do have to, just like multi-threading, you do have to be concerned about like race conditions, data safety issues, depending on what all is happening, right? So you can imagine I send a network request and then I have an update from the user, I want to do something different. I've changed my state. I send the new networking request that I kind of want to supersede, but the old one comes back. And I think it's an answer to, you know what I mean? Like, you have to manage that wait a minute, like I have to be really careful. I'm doing more than one thing at a time. And so you can end up with all of the traditional things you would hear about related to sort of thread safety, being careful, making sure that, you're aware of whether the data structures like queues and other things you're using are multi-thread safe, even if you're only doing async stuff, because you can end up in these weird situations where out of sequence stuff is occurring or overwrites, or you just need to be aware that it does add a lot more complexity to the system, but there's a lot of gains to be made in many situations.
Yeah, totally. And this is really what separates kind of like masters of their craft from apprentices. It's like all of the lessons learned around, we got burned this way or that way, or the database kind of like fell over because we weren't monitoring it. And what it really comes down to is just setting up a ton of monitoring and constantly tweaking the knobs. It's if the machine is like mostly idle, then maybe it can handle more processes. But if processes are getting backed up, why are they getting backed up? And so there isn't there isn't a system you're going to build that has concurrency that's going to work perfectly for the first time and forever. As the load profile changes, you'll have to adapt to it, and it becomes kind of a living system. This is pretty unavoidable. So async, helps with, all of the mistakes that come from multi-process. Async, you can eliminate a lot of those as candidates. Like if we were basically building async ourselves, we'd have to wonder, did I get the process pool correctly? Am I releasing the semaphore at the right time? And so because of async, you don't have to worry about that, but the consequences you still have to deal with.
You bring up a really good point, actually. I think if you're going to go to this approach, so there are some like UI frameworks I feel are much more commonly written in an async at the framework level, because you want to make sure that the user interface stays responsive. So you shouldn't ever do anything blocking. And so they're actually really set up from the start to be asynchronous. But people who write that, well, I should say a lot of people I work don't write UIs. They're not actually even familiar with that. And as you pointed out, if you ask them about it, they wouldn't really be aware of like the nuances of these trade-offs and the decisions and the complexities and measuring and all of the parameter, like having reasonable parameters and monitoring whether or not like they're set well, would just be stuff not present. So it is really weird. Like on the one hand, it's common enough that you would sort of say like, it's in every UI framework to have like asynchronous stuff. What do you mean? Like people don't know what it is, but it's like this very weird division of practitioners where sort of like, I think there are whole classes of people who go a very long career without really getting into any of it.
Yeah, totally. Which is why you need to subscribe to Programming Throwdown. It's a perfect segue to our outro. I mean, we I feel like we gave a pretty good background. I think the sort of maybe the call to action here is really learn async programming. I mean, if you're doing UI stuff, you pretty much have to. I think it's at the point now where I think Android and iOS, if you try to do a network request on the main thread, it'll just like give you an error, like a runtime error. It just literally will not let you use the main thread to do non-blocking stuff. So it's a non-starter. But even if you're doing anything with distributed, anything with queue processing, you'll encounter this in some way, shape, or form. So if this is all new, definitely dive in. This is an area that's worth learning. I think with AI and agents and all of these things, it's going to become even more important. An agent might send a text message and wait to get a response from somebody, and it can't just block the machine while it's doing that, right? You want to run like 10,000 agents on one machine. So super important area. I think that it's definitely something that's worth researching. And if you have any questions, you can always go on Discord. The Discord channel is getting more engagement. I always try to reply to stuff on there. So check us out on Discord. Shoot us an email, and it's great covering this.
Yep. Thank you, everyone.
All right. Catch y'all later.
Music by Eric Barndollar.
Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.